It may come as a surprise to some, but I haven't really listened to my car stereo in close to a decade. Not beyond the few minutes that it would take to film whatever silly contraption I happen to be testing in there. But today, I'll make a half-serious effort to change that with a 3D scanner. So, we all understand the basic premise behind a 3D scanner. It projects a pattern of light onto an object, which is then captured by a series of depth cameras to form a point cloud, later reconstructed as a 3D mesh. This is what Revopoint does to impress the ladies, and here's the recently introduced standalone scanner. MIRACO is what it's called, and a built-in computer is what makes it standalone. We'll get into that, but in terms of the first impressions, with the flippy screen and all, the thing feels just like a well put together camera. There's no creaks, no rattles, this thing is solid. The initial boot up sequence takes us through the setup, and seconds later, we are ready to scan. This is where you bust out the little turntable, a topper with some tracking markers, and you scan a thing, the idea being that afterwards you can print said thing, and that's generally the pitch. As a design engineer, most of my time is spent working around the existing geometry rather than making copies of it. Nevertheless, in this video, I will show you how a device like this becomes invaluable in an acoustic professional's toolkit with a good old-fashioned car audio project. This is my second-hand grocery getter, a 2015 Chevy Sonic hatchback. Just cheap enough to buy cash, and just reliable enough to serve as my only set of wheels while I'm out here in Missouri. The back seats fold, so we've kept them down for the laundry, shopping, and the occasional bit of nonsense. Beneath this comedically flimsy cover, there is a compartment roughly 14 centimeters in depth. And I say roughly because nothing remains consistent as I measure across the way. Also, this false floor isn't helping, so let's get rid of that for some extra depth, and yeah. The amount of dimensioned notes that I need to define what I'm seeing here would likely span several pages of some very tedious scribbles.
Ain't nobody got time for that!
Exactly. And this is where the humble tape, pad and pencil combo takes its leap to make way for how we do things in 2024. Suffice it to say, a number of my personal clients already communicate their measurements by way of 3D scans, generally done on something that has to remain tethered to a laptop. Meanwhile, the MIRACO is an 8-core, 2.4 GHz computer with USB, Wi-Fi, a 9-axis accelerometer, 16 GB of RAM, a 256 GB hard drive, and software for editing scans and converting them into meshes which can later be exported over Wi-Fi or USB. There's also 2 sets of depth cameras, one set for the fine up-close detail, and one to capture the larger, less feature-rich areas. You can even pause the scan to switch between the cameras and the various capture modes. Really, the only thing that's missing is the tricorder sound. So, in literally a tenth of the time that it would have otherwise taken me to jot everything down, I have a mesh of all the geometry around which I can now design. Knowing, for instance, exactly the distance between any 2 points, or making sure that I clear important mechanical features like these guide channels for the hatch cover. So, now that I know exactly how much space I'm working with, it's time to figure out how best to use it. Granted, the half-ass approach would have been to simply bogart the entire compartment, slap a pancake sub in there, and counter the inevitable lack of bottom end with bass boost, inadvertently driving the piston into overexcursion rather than a solid, effortless extension down to 30 or so hertz. Not a recommendation. Moreover, as it stands, I don't even know the correct piston area for what I'm doing, and to establish this, I'll need a frequency response of just the factory speakers along with a peak hold decibel reading of the stereo playing at volume. This informs both the shape and the amplitude of what I'm extending from. As you can see here, the factory speakers do okay down to about 60 Hz, and, while playing at volume, the acoustic pressure reaches 110 decibels. So, here's what extending things down to 30 Hz at volume would look like for a subwoofer. Now, I just have to work backwards from this target to dial in the appropriate piston area, driver type, acoustic arrangement, etc. And if you're curious about the details of the engineering process, I also have an entire presentation on just that topic. Anyhow, after some due diligence, I discovered that I'd be able to achieve my target with just a handful of these 4-inch mid-bass woofers from Dayton Audio, which you might have seen me use in a couple of other projects. These are literally just the 8-ohm versions of the same, and given the available space, a total of 6 drivers in this dual 6th order series tune arrangement should carry the music down to 30 Hz at volume without the bottom end having to be electronically boosted or the subs coming anywhere close to over-excursion. Best of all, at just 150mm tall, the enclosure will fit entirely beneath the cargo cover. There's even a landing for the tiny audio dynamics amplifier, delivering about 200 watts to the 6 drivers ran in parallel. Anyhow, let's get the sawdust flying, and as I cut this 8-layer sandwich, I should also point out that all the external dimensions for this project are based exclusively on my Revopoint scan. So, for instance, whether or not we actually achieve this 11.5mm gap between the enclosure and either of the 2 guide channels in real life won't be known until I drop the thing in, fully assembled. Speaking of, with all the MDF cut, it's time to begin stacking the layers. Here's a healthy coat of Tight Bond 3 for adhesion, and a bunch of these 1/4-20 screws for both the alignment and for delivering some clamping force as the glue sets. Over here is where the speaker wires come in, so a little squeeze into the notch. The cable is slathered as well, and there it goes, perfect seal by the next layer. This continues for another several hours of mostly just waiting for one layer to set before stacking the next, with lots of Minecraft in between, but eventually the 2 mounting baffles are ready for a quick test fit. I'm actually quite happy with that, so let's get these glued in as well. Finally, before the top goes on, all the individual cables are spliced in and wrapped in closed cell foam to keep from rattling. Here's layer 8, sealing it all in, and once everything is bolted down tight, I move onto the access panels. For this, I've gone with a 6mm cast acrylic. It's cheap, it's strong, and you can see through it on the off chance that something inside needs looking at. So, these are going to sit in there like that, and just as a final touch before I make the gaskets, we've got Sophie over here brushing on the exohide. Afterwards, I brought the CO2 laser back out to cut some of this closed cell foam, and there's our gaskets. These are held in with contact cement, while the little gaskets included with the Dayton drivers receive a layer of Blue Tack under each mounting ring. This is where everything gets loaded in, and no, I'm not painting the internals or doing any LEDs in there. After the video, this isn't going to be seen by anyone, in fact that's kind of the entire point, so with the access panels firmly attached and the amplifier hanging on by a couple of wires, the contraption drops into place exactly as modeled. Well done, Revopoint! All that remains now is to wire up and mount the amp, followed by a moment of truth. Ultimate stealth. Better still, the floor is now supported for much heavier stuff to go on top, which I tested right away as I needed more MDF for another project. Anyway, here's the in-cabin response, and it is bang on. I even ran a second one with subwoofer turned up just to distinguish its contribution from the rest of the speakers. There will be a demo at the very end, in fact I wouldn't do it justice if I didn't cue up some proper, copyrighted music. As it happens, YouTube doesn't make a very strong case for monetization, and given that I have an actual job, if not several, I am less than rattled by the prospect of some of that $70 going away. So, before I shake the living shit out of your headphones, here's my overall take on the MIRACO. It is a $1,000 tape measure for anyone whose time is worth a lot to others. If you were to contract someone like me at $50 to $100 an hour, the last thing you need is to watch me fumble with a caliper in some difficult-to-reach corner, wasting the morning extracting a mere fraction of the geometry that a 3D scanner would otherwise capture in seconds. What's more, even simple projects around the house stand to benefit from the same convenience. Here's a porch light that we literally never use next to a piece of shit security camera that I hate having to take down in the time I replace the batteries, so that's just stupid. Instead, I figured I'd simply remove this whole fixture, scan the part that interfaces with the mounting hardware in the wall, and design my own thing to go in its place. In this case, a waterproof housing to hold one of these newer blink cams, along with the included power brick. Needless to say, everything aligns perfectly, and once installed, no more batteries, yet still a porch light. So, in the end, the scanner represents a significant quality of life upgrade for the DIY hobbyist, and a massive boost in productivity for the professional designer. Such has been my experience anyway, so that is where I'll leave it. Don't forget to rate the video as you see fit, subscribe if you're so inclined, and I'll see you in the next one. Cheers!